Hey everyone, today we're going to tear apart what a fully automated MLOps system really looks like. We'll show you how to build a machine learning system that doesn't just get deployed, but one that actually lives, breathes, and evolves all on its own.
So, picture this. You've done all the hard work. You've trained an absolutely brilliant model, you've pushed it to production, and it's out there serving predictions. But here's the big question. Now what? Is that it? Is the story over? Not even close.
See, in reality, deployment is just the starting line. The real goal is to have a system that tracks its own health, manages its own life cycle, and knows exactly when it needs to evolve. So how do we actually build it? Let's dive in.
Okay, first up, we have to solve the problem of chaos. When you're running automated training pipelines, you can very quickly end up with this overwhelming number of experiments, making it pretty much impossible to keep track of what's what. Just look at this. This is the history of our automated pipeline runs. Every single line is a new model that got trained. How on earth are you supposed to manage this and confidently pick out the one single best model for production? Well, you get to this. A clean, simple, and totally authoritative registry that tells you exactly one thing. This is the champion. This is the model that's live right now, serving predictions to your users. So, how do we bridge that gap from total chaos to perfect clarity?
We do it with a tool called MLflow, and you can think of MLflow as a super meticulous librarian for your models. For every single experiment, it carefully catalogs everything, giving us a central source of truth for the entire model lifecycle.
MLflow records three absolutely crucial things for every single run: the training parameters, the performance metrics, and the artifacts, the actual model file itself. This makes sure that nothing ever gets lost.
And this shows you the result perfectly. On the left, you can see the raw JSON data that MLflow is capturing, every metric, every parameter. And on the right, you can see how our application can just pull that data and present it in a clean, human-readable summary. We know instantly that version 279 is our production model, and it's hitting an 84.8% accuracy.
But here's the magic. We're not manually promoting these models. The system has its own logic. Whenever a new model is trained, the pipeline automatically compares its F1 score to the current champion. If, and only if, the new model is better, it gets promoted to the production stage. In our API, it's hardwired to only ever pull the model with that production tag, which means we are always serving the absolute best.
So we've got the best model in production. Fantastic. But now we have a totally new problem: blindness. How do we know if the system serving that model is actually healthy? Is it fast? Is it reliable? Is it even up?
For this, we need eyes on the system, and we use two tools that work together beautifully: Prometheus and Grafana. Prometheus is the data collector. Our API is constantly broadcasting its vitals from a /metrics endpoint, and Prometheus just scrapes that data every few seconds. Then, Grafana acts as our mission control dashboard, turning all that raw data into these beautiful, intuitive visualizations.
Just take a look at this number. 477 nanoseconds. That's the average response time for our API. That is incredibly fast, but it's just one little piece of the puzzle.
Let's move to the full dashboard and see how this all comes together. This is our complete view of the system's health. In the top left, you see that big green up status, which is honestly the most important metric of all. At the bottom, we're tracking system resources like CPU usage. And right there in the middle, we have our model-specific metrics like F1 score and accuracy. We have total visibility.
But visibility isn't just about looking at pretty charts. It's about being proactive. We've set up alerts in Prometheus that watch these metrics for us. So, the crucial point is, if our model's F1 score ever drops below 60%, as you can see in this rule, the system doesn't wait for us to notice. It alerts the team immediately.
All right, we've solved versioning and we've solved monitoring, but there's one last, much more subtle enemy we have to fight: the silent killer of machine learning models: data drift.
Data drift is what happens when the real-world data starts to look different from the data your model was trained on. And even if your system is perfectly healthy and your code is perfect, your model's predictions can become totally useless just because the world has changed. So what's the solution? Do we just retrain the model every hour? Every day? That would be incredibly expensive and really inefficient. There has to be a smarter way.
And of course, there is. We use Evidently AI to constantly measure data drift. It statistically compares new, live data to the model's original training data.
If the data distributions stay pretty similar, say below a 10% drift threshold, we do nothing. We save those compute resources. But if the distributions diverge significantly, that's our signal to automatically trigger the full retraining pipeline. And here's the proof. If we go back to our experiment history, just look at the timestamps. These training runs aren't happening on a fixed schedule, not every hour or every day. They're sporadic. This system isn't reacting to time, it's reacting to the data itself. It only works when it needs to. That is true automation.
So, let's put it all together. When we combine these three solutions, what does the complete automated system actually look like?
It all comes down to these three pillars. MLflow provides the quality gate, making sure only champion models ever go live. Prometheus and Grafana are our mission control, giving us constant eyes on system health. And Evidently AI is the intelligent trigger, using data drift to decide exactly when to retrain. Together, they create a system that runs itself.
And that brings us to the most important takeaway. In MLOps, a great model is a fleeting victory. Data will always change, and that will render your model obsolete. But a great system, one that can manage, monitor, and evolve itself, that provides lasting value. So are you building models, or are you building systems that last?